Okay, let's pick up where we left off with the box problem. We'd created our volume equation using our variables width, height, and length. And we established the domain has to be between 0 and 10. And so if you graph the derivative, you're going to get a critical point. And the critical point is crossing at x equals 2.347. Now you store that for some more accuracy, and that will produce a maximum. And so we wanted to establish what the dimensions are of this box. And so our width, okay, I'm going to store that in a value. Okay, I'll just store it in alpha q. And so my width would be 20 minus 2q. And my height, of course, is just going to be q itself, so 2.347. And my length of the dimensions would be 25 minus 2q. All right, so our width ends up to be 15.307, and our length ends up to be 20.307. And so altogether, those dimensions would work to give us a box that had the largest amount of volume, that would hold the most amount when it was put together. All right, our final example is one that's going to be working on a minimum. Okay, a minimum surface area for a cylindrical can. So think like a can of Pringles maybe. Okay, something like that, or maybe a soup can or something, but a Pringles can with a fixed volume of 1,000 milliliters. So let's work kind of through our steps here. Our goal is volume. Excuse me. Nope, see, I didn't read it right. Our goal is surface area. All right. Our variables that contribute to the surface area of something. We're going to need a radius. We will also need a height. And the equation for the surface area, all right, well, the surface area has two circles, one on the top and one on the bottom. All right, so it's got a surface area here and a surface area down there. So the area is 2 pi r squared. But the surface area also has lateral surface area. So it's the area, think of like the soup label that goes all the way around the outside. Okay, and so that has a height, but it also, if you unwrap that label, it's going to look like a rectangle. Okay, if you sliced the label off and unrolled it, it would just look like a rectangle. Think about like a paper towel. When you take the paper towel off the roll, you tear it off. The shape of that is a rectangle, okay, but it was around the roll of the paper towel. So this has a height, but the base of it is the circumference of the cylindrical can. So the total surface area for that is 2 pi RH. All right, so that's our equation. We're not quite ready to do a derivative yet because this equation has two different variables. It has r's and h's. So we've got a radius r and a height h. But we also have this little tidbit of information that the volume is 1,000 milliliters, which is 1 liter. Now that's going to help me out here. That's a little bit of an extra bonus. The volume of this equation is pi r squared h. That's the volume of a cylinder. The volume is 1,000. Now that will allow me to get one of these variables alone. And it looks to me like h is the easiest, so that would be 1,000 over pi r squared. So rather than use height as the variable h, I'm going to use the expression 1,000 over pi r squared, which means I'm going to change my surface area equation to be 2 pi r times 1,000 over pi r squared. Now we're ready, now that we've done the geometry and the algebra, now we're ready to do our derivative. So I would put this equation into my y1, and then I would graph the derivative of my y2, and then see what I can find in terms of the minimum this time, because that is my goal. Now when you put this into y1, go ahead and just use x for your variable, so 2 pi x squared plus 2 pi x times 1,000 over pi x squared. Now make sure also that you put these two things in their own parentheses, because we could simplify this. We could reduce the pi's, so we don't need that, and we could reduce the r's. So my denominator is really just 2, and then I've got r, so that'll make it simpler. So maybe 2,000 over x when you type it in. Okay, so when I graph my Math 8 derivative, I used a window of 0 to 10, and I used 0 to 10, and then I did negative 10 to positive 10. That was my window. You could have a different kind of window, but I came up with the graph that crossed here, which is the spot where it's going to be a minimum because it's crossing from negative to positive. So my critical point will be the value where it's crossing the x-axis, which ends up to be 5.419, which I'm going to store in Q. This is going to be a minimum, and so then I need to make sure I answer the question. And so the question is, what is the surface area? So I need to take that Q value and plug it back in to the equation for surface area, which I happen to have stored still in my y1. So I'll have a y1 of Q which turns out to be 553.581. All right, and then the units on this, I was given a volume of a milliliter. A milliliter is a cubic centimeter. And so the individual, the surface area will be measured in square centimeters. So this would be centimeters squared. Okay, that's because 1 milliliter is equal to 1 cubic centimeter. So the metric measurement is in centimeters. So length and width and radius and height and volume and surface area will all be measured in the unit of a centimeter, or square centimeters, or cubic centimeters. All right, so hopefully you'll be able to work through these word problems. Now, the first 3 are going to be your toughest. Okay, you're going to have to reach back into some geometry, formulas for variables there in your appendices of your book. So if you go to the back of the book, you can also Google. If you don't remember how to find the volume of a pyramid or a cylinder or a cone, or just Google it so that you have a equation to work with. That's going to be the hardest. Once you've got it, then the process after that is the same. You're going to put it in y1, you'll use your Math 8 derivative to look at the graph, and you'll narrow it down to the critical point that is the max or the min, depending on what the question is. So I readily admit that the first parts are going to be tough. So work with friends, reach out, and yeah, we'll get back together again on Thursday.